is on linting. Linting is, it might have the same feeling of the complexity of TypeScript, but it is way, way, way less to think about. It's all to do with style, right? Style's easy. Who finds it easier to clean up white space than to debug your code? Okay, everyone with their hand down's a psycho, I guess. But it's like you can't fix your style forever manually. We know that it just takes a lot of time for large projects. It's not feasible. So we need automated ways to do this. Programs are written for people to read. I think this is always really important. This is just pretext as to why style matters so much. I used to, back in my angsty late teens, I wrote on my desk "Coders for Humans" once. When when you're like an angsty teen and you write quotes down or something. I had this old friend who used to love it. They peppered their bed, on the top of their bed there was just little printouts of little animals saying you can do it and all that kind of stuff. And I thought it was so cute. So Coders for Humans. Programs are written for people to read. They're not written for computers. So obviously style is really, really important. And it's important that it's consistent. Consistent style rules are one thing, but making sure that we follow the rules is a whole other thing. Again, having a style guide that you can follow, cool. If you give a rule book, a 5-page PDF to 10,000 people and you ask them to follow the style guide, you will have a hell of a lot of people not following that style guide. So today's not really about the importance of a style guide. It's about how do we enforce the style guide in an industrial way. So obviously coding style is important. Bad style, good style. See, really easy lecture, isn't it? It's that looks bad, that looks good. Style is important. How do we enforce that? I always try and the very first piece of code I wrote is a marvel in ugly code, and I want to go and find it. Maybe I'll find it for next week. I know I keep saying that and then I forget, but we'll do our best. So before we get into how we enforce style, there's another industrial question we have to ask, which is who decides on style? And there's really only two ways that a style in an organization is decided upon. The first one is that a person, well, when I say decided upon, I mean how does a style guide come to be? Most places will pick a style guide that someone else has written. There are companies out there, I don't know who, Google, I guess. Maybe we'll do Google JavaScript style guide. And I'm sure, yeah, Google's got a JavaScript style guide, which is very lengthy and has a bunch of stuff in it. So why would you go and write your own style guide if Google has already decided what they think, or a bunch of other companies have, right? Hundreds of engineers over many hours have thought very deeply about this. So you go and take theirs. There's no IP problems with that. It's not like a fighting area. And then sometimes you might go and modify specific rules. Maybe if you're a team of researchers and there's 5 of you, and Google really says that, when you create a function, your function should be like this, and then you should always have the braces on the next line, And maybe you and your 5 friends that you're making this project with are that is sinful. I hate that. So you go and change maybe a couple of rules, right? That's basically how style guides come about. But I think more fundamentally, 95% of people will never contribute to a style guide. You'll just be told how to write code. You'll be given the rules. And you'll be I think this. And then someone who is probably older than you will be I don't care. And then you'll get back on with your day. And that's, that can suck for a little bit, particularly when we're early programmers and we're quite engaged and we, feel very strongly about it. But that feeling does dissipate pretty quickly. Regardless of who decides on the style guides, we have to enforce style somehow. In early computing courses, you're often given style guides and guidance and stuff and told to make sure it complies to the style. But when we talk on the topic of tooling, in particular static tooling, we'll often refer to these things that check your style and enforce your style as linters. It comes from these little lint rollers. Who's ever used a lint roller? Who's never used a lint roller? It's all right. I was 26 when I used it at first, and then I realized that was a dysfunctional behavior to get that old. So go use one someday. They're good fun. They make your clothes less hairy. I just start using it. Does anyone have a cat? Yeah? 3 of you? 4 of you? Yeah? I lived with a cat, and that's what made me get a lint roller, because I had cat hair everywhere. So lint rollers, they clean things up, right? Pretty simple concept. So what does a linter do in the context of computer science? if we think about static verification as the process of analyzing as much of your program as we can before running it, and we think about style as something we can look at before we run it, a linter is just a form of static checking that mostly checks on two things. Style issues, as you would understand it, which are things like white space and indentation and where braces go and are there spaces between commas. And a lot of linters also check what we call semantic issues. Semantic issues are things like bad logic and potential bugs. Because the thing is, tools that check style are really simple. TypeScript is a complicated beast, you know? Think about all the crazy stuff it's probably got to do. But linters that are checking style, they don't really do a lot. They don't really track all these variable types, but there is a basic thing they can do. If you have I don't know why I'm writing this out again. If you have a function called name, and this is a funny function, isn't it? And you say like, you know, console log A, linters can usually be like, A doesn't exist. I don't see A anywhere, Hayden. That's a problem. So linters do have some basic, what we call semantic checking, which is like, does your code have like possible bugs in it? TypeScript would have that. So there would be a little bit of overlap between like what linters can check and what TypeScript can check. But day to day, most of us think about linters as tools that help us make sure that our style is good, not necessarily the semantics. The limitations of these linters that enforce good style is they are, like any computer, unable to infer some things. They can't tell you if you have a poorly named variable, you know? They can't do anything that's more human because they're just computers at the end of the day. And that's important to note here, because a linter or a tooling to help with your code style will drastically improve the amount, like reduce the amount of time you have to spend thinking about your code style, but you always still have to think about your code style because there are things it just can't check. In the world of JavaScript, the most popular linting tool that exists is a tool called ESLint. It's a funny sounding name. ES stands for ECMAScript, which has nothing to do with, like, seemingly nothing to do with JavaScript, but the actual documents that define how the JavaScript language is written is called ECMAScript. Don't ask why. It's a weird world out there. But you can think of it, even though it says ESLint, the ES just means JavaScript. You could call that JSLint. So don't be taken back by the name. So we have this tool called ESLint, and it is an extremely popular tool for statically analyzing JavaScript code. There would be other tools to look at JavaScript code from a linting perspective. There are tools in other languages. In Python, they have a tool called PyLint, you know, that tries to lint the code. So it detects all the errors and style changes and stuff, and you can install it just like Jest, just like TypeScript by, I'll go to the right folder now. Whoops. By going npm install save dev ESLint. And that will go and install the dependency onto your computer, just like you're used to. Now, the thing about ESLint, though, is that ESLint itself does not have an opinion. ESLint is a enforcer of the laws, right? Like, think about the police. The police don't write laws. Parliament writes laws. The police just enforce them. So ESLint is an enforcer of the law, but they don't write them. The writing of the law, rules, whatever, is really up to the organization. And the good thing about ESLint is that it's really simple. There's actually one file that exists. It's just one file, and it has all the rules in it. Sometimes there's not, like, the rules aren't written explicitly. Sometimes they're kind of like referencing, like, hey, it's all the rules in Google's style guide plus a few extras, so they can be quite small. But we can actually see that because in our, let me find it here. Where is it? Oh, it's hidden. It's a hidden file because it's got a dot in front of it. You know how files with dots in front of it don't exist? I should be able to open it, though. Let me try. Oh, where is it? I might have accidentally, because if anyone's noticed this, when you copy files on Linux, sometimes they don't copy right. But I can easily go and grab one from a lab. So when you look at your labs next week, you'll see that from labs 4 and stuff, I don't remember which exact lab it's in, you'll start to notice that as of next week, that a file starts to, I feel like I'm losing the plot now. Maybe it's the other one. Where is it? Yeah, okay. Sorry. So from week 5, I guess. I don't remember the exact week it comes up in labs, but you'll start to see this file appear that's like, it's called ESLint-RC. And ESLint-RC is just a file that describes the linting rules. It's a big file. It's a pretty straightforward file. It's like package.json. It's often in JSON, but it can be in JavaScript, but it's always called ESLint-RC. And it just says things like, what's one that makes sense to us as we read it? Because a lot of these you have to Google. Like you might be like, oh, what in the world is no object calls? And then you Google it, and you see that it's like you go to their website, and it says disallow calling global object properties as functions. And then you're like, what does that mean? And then you read through it some more, and it probably still doesn't really make much sense to me right now. I don't want to spend time on it. But there's like, a lot of them do make sense if you just spend more than 4 seconds looking at it. But this is an easy one. No mixed spaces and tabs. So you can't use tabs and spaces to indent. You have to use one of them. And all of these specify what to do if those things come about. So these are all saying error. And what that means is if you do them, you're going to get an error. ESLint is going to stop you and complain to you. So that's what the ESLint-RC is. You can make that, obviously, for the sake of the course. We always give one to you. We have like the 1531 guide, and you have to work with that, and that's important. But then running ESLint's also pretty easy to do. It's just like everything else we've seen. So if I come here and I look for the 3.4 code, I've got this program here, this bad style code that you saw at the start, where everything's kind of all over the place. And I could go and check out, I could use ESLint to find the problems in that code. I could go node modules, ESLint, source/3.4, what was it? It was style bad, like that. Oh, don't do that to me. Oh, it didn't exist, that's right. Let me copy that in from, again, be careful on Linux machines, because if you just do a plain copy, it won't copy hidden files. So I'll add that ESLint rc.json, paste that in.
Is it .json or .js?
It can be either. It can actually be .json, .yaml, or .js. Generally, JSON's probably the most popular I've seen. Wow, no problems apparently. Don't trust it. Let's try and, let me check. Oh yes, this is silly me. I always forget this, but there's actually something that you can add to your files that you're not allowed to add because you get in trouble. I used to say that, but it was just a blank threat. But I do actually have systems now to find you, so it's a serious threat now. But if you add random comments in your code, there's very specific comments you can add that just like shuts ESLint out. So if you add this random comment to the top of your file, ESLint just like, it's like goes invisible. It's like Harry Potter invisibility cloak kind of thing, just gone. ESLint can't see it. So that's why that passed, because I was like, nothing's here, nothing to see. But if we run it again without that, we'll actually get the errors. Thank you. Who pointed that out? Was that you? Thank you very much. That literally stopped the lecture being destroyed. We can see a lot of problems here. It says, hey, a space is required after the comma on line 1, character 13. There's missing space before the opening brace, line 1, character 16. So it's a nice, really thorough list. And what's even better is that the list actually tells you, if you get a description that doesn't make sense, you can actually just look at the rule. Because the rule there will tell you, like, oh, that's where the rule comes from. Question?
Is there a way you can get to fix it as well? Or do you have to go in and fix it yourself?
Is there a way to get it to fix? So style issues can be fixed manually, but we're lazy. So we can add a -- fix flag to this stuff, which makes things even easier, because if you run the command like this, and you just go -- fix here, it will actually go through your code and actually clean it up. Now again, it can't change the stupid variable names, and there's limitations. Like, it's not going to make your code perfect, but it really just did that kind of change there. So it's able to look at the rules and interpret them. ESLint rules are just rules people make. I wrote one for work over summer that was kind of a fun little project, and basically it's just something that reads through your code and can rearrange it. But that's the gist of it. You can ignore one-off issues in your code if you want. Sometimes there's really weird errors and you can temporarily or permanently ignore them by adding in various lines. There is a link in the lecture slides that show you how to ignore lines. Don't do that unless you've talked to your tutor as a general rule. In your project, we actually will add some hot commands. I don't know why I called them that. We'll actually add commands for you where you can actually just run npm run lint like that, and it will lint through all of your code, or you can run npm run lint fix, and it will run through your code and fix everything. So those commands are given to you. It's a very short lecture because linting's not complicated to explain, and we're right there. Got about a minute left, so I'll be quick. You can also add it to your continuous integration. Surprise, surprise. Isn't this cool? Now we can lint, TypeScript, jest our code. Improvements. Really straightforward. This comes into labs from week 4, though. I didn't see it in the config, so I have to double check that, but assume it starts next week. Projects iteration 2. Ignore that. These aren't important. And that's it. So that's linting in a nutshell. Thank you, everyone, and I'll see you on Tuesday where we get into even more fun stuff.